All right, this is a quick tutorial on how to use Overleaf as your LaTeX editor. So Overleaf is an online-based LaTeX editor that lets you easily write and then compile LaTeX code without actually having to download it and install the necessary compilers yourself. So the first thing you need to do is go to overleaf.com and then log in. So we'll go here and then go to log in. As a student at UW, you can log in through your institution. You'll have the free version of the Overleaf tool, which doesn't have certain features available. You have to pay for a subscription if you want those, if you want, say, like track changes or that kind of functionality. But with the free version, you can at least write your own documents and share them with a limited number of people. So to do this, you come to the login page and then log in through your institution. You'll type in your email address, and then it'll send you to the login page for your institution. So I'll go ahead and do that now. Once you've logged in, you're going to see a list of your documents or projects that you have available. It's similar to what you'd see in any other editing software. So here's all the projects I'm currently working on. I'm going to switch over and use our paid subscription account, which has some additional functionality. But this is how you would log in and have access to the free version. So this window is showing the list of documents. We're going to play around with a thesis template, and I'm going to use that to show you how to write LaTeX documents and have it compiled with Overleaf. So you click on the project, and then it's going to open the code. The first thing let's talk through is how this is all organized. So in this window here, you see the text that you'd actually be writing. So we'll be typing and making changes in this window. The first thing you'll notice is a lot of commands and special stuff going on. Don't worry about that. That's not really the bulk of LaTeX. But you'll have, this is where you'll be making the changes and additions to your document. Over here is the display of the current compiled version of the document. And then over here is the project structure. So unlike, say, a Word document where you have everything in one window and you're typing in the text and making changes there, the way that LaTeX works is you provide text and you provide commands that typeset the text and format it and add tables and et cetera. You're doing that in plain text. The behind-the-scenes compiler will then render your text and commands as a PDF. So in order to do that, you can have multiple files that are included in a project. You can have separate graphics that are included. So there's a lot of benefits of organizing the project in this way because you can control, from multiple files. You can have, say, your first chapter in one file, your second chapter in another file. You can have your bibliography entries in a third file. You can keep everything neatly organized and then bring it together when you actually want to compile the project. So here on the left-hand side, you see this structure. The thesis itself is a pretty relatively complex project. It can be as basic as just having a single .tex or tech file that can be compiled, but for these larger projects like a thesis, you're going to have maybe multiple folders with figures and different source files, et cetera. So for this project, we have the main file, which is our dissertation.tech. And in the main file, we're setting up the project, providing information like our thesis title, our student name, our advisor names, et cetera. And then going through and providing typesetting options that we could talk about later. So this is the main file. The actual text that we're entering is going to be somewhere else. So let's look at our document over here. We have our thesis, the title page. Again, we're using a template here. And this template is provided by the University of Wisconsin. And in this template, it sets up the title page for you. It sets the margins and the spacing and the font so that when you submit your thesis, you know that it's compliant with the requirements for your institution, for this particular institution. So all of this is done automatically for you. A table of contents is automatically generated based on your sections and headers and things. So let's look at actually where you might start adding the contents of your paper. So here in the first chapter, we have our introduction. You'll notice right now there's just this placeholder placeholder text. What you can do is over here in this window, if you want to access the code in the place where you're seeing it on the window, you hold down the control key on your keyboard and then double click, and it's going to take you to the code where this is actually defined. So we have this this command here is our what's called the lipsum package, and it's just providing some dummy text. I'm going to comment this out, and I'm going to start typing my own document here. So we can type anything we want. So I'm just going to enter this text, and if I want to see how it looks, I can then recompile or hit Control Enter. And now you can see that this document has been rendered by the Overleaf service for you. So this is what the thing I typed. You can see that I've added a table below here. You can format the color of text and tables using this color command. But tables are a little bit different. So instead of working directly with columns and dragging, which is actually commonly a pain point in dealing with programs like Word, here we just give it the information that's needed to render the table, and then separate the columns and rows by either ampersand for column or double backslash for row separation. So this is a really simple table example where we have our header line. We have these different columns, right? So this might be column 1, column 2, and so on. So we provide that information as the header line, and then each of these are rows in the table. So A, B, C corresponds to A, first column, B, second column, C, third column, and so on. If we want to add a new row, we would just continue on down here and add the information as we need to go. If you need to reorder the rows, you can always do that either by cutting and pasting, or in Overleaf there's a shortcut where if you hit Alt and then the up or down arrow, it'll actually move the row up or down. So that's really a very convenient way of moving information around. Now we can recompile this and see how it looks. So now I have our new table with our updated labels and new information. Let's say I have this entry, and in my final edit, I decide, in fact, I don't want to have this third row. You can keep the information in there, but you can actually comment out lines in LaTeX. And the way to do that is you go to the front of the line and add a %, and you'll see the line turns green. So this row, this line now becomes commented out. Right? And this is true of anywhere in the text. So if I wanted to comment out the last part of this line up here, I could do that. So anything between the % line and the end of the line you're on will be commented out. So if we compile this, now you'll see the table renders without that commented line, but I preserve all that information over here. So if I am going through my document and I have parts where I want to make comments, notes to myself, or maybe notes to a co-author, or I have pieces of information that in my thesis I want to present, but in some other publication, maybe I'm going to make this a journal publication, I don't want to present that information. You can easily keep that information in the text document, but not render it in the final product by commenting and uncommenting lines. There is a shortcut to do this, so if you just hit Control \, it will toggle the comments on and off. So let's quickly talk about some of the best functionality that LaTeX provides. And that is in rendering equations and automatically numbering equations, figures, and tables. So here in this table example, you can see that there's a table environment. We denote the table environment by saying begin table. There's specifiers on the preference of whether the table is supposed to be rendered here, as in where it's presented in the text, or the top, bottom, or on its own page. So you can provide any of these specifiers for a table or a figure, and it will automatically try to find the best position for the table based on your order of preference. So here we've said, first we prefer to have it here, as in right after this line. But what if we decided we wanted to prefer to have it either at the top or the bottom of the page? I could provide a new specifier that looks like this, and when it renders it, it's going to, based on the spacing and position and overflow and all that, it's going to find the best between the options you give it. So here it says, or it's decided that the bottom is actually the best option. If I want to force it to be the top, I can do that by saying T exclamation point. And it will essentially force the table to be at the top. And now you can see why it put it at the bottom, because it doesn't like to float items like a table outside of the section that it's actually defined in. So let's go back and leave it the way it was. Let's talk about the automatic numbering and references. So you'll see that we've got our table. We provide a caption for the table. And then here's the actual contents. The tabular environment is here. So we say begin tabular environment, and the tabular environment has 3 columns, left, center, center. And then you find all that here. But the label and figure, or label and table functionality is provided here. So we have this command, \label. We're going to label this table to be this, whatever we decide to call it. We're calling it, in this example, tab :1, so table 1. This unique label can be referenced anywhere in the text, and it'll be replaced by the number that corresponds with this table. So here I've got this command ref. This little tilde is just making sure that there's a space between table and this, so we could replace that. So I've got this ref, and when I say ref the same key as the label, it's going to automatically replace the number of the table in the text based on its position. So you can easily move stuff around, and it'll automatically update the numbering for you. So you can see, as it's rendered over here, we have table 1.1. That corresponds to the label that's given here in the contents of the table. So we could do the same thing, maybe repeat this. We have a second table, and let's label it 2, table 2. So I can do the same thing, present table 1 and table ref tab 2, and then compile, and you should see then the second table appears, and the second numbering automatically goes with it. Let's also look at how figures work. So in this example document, I have a figure. Again, I'm going to control and then double click to get to the source. So here in this lit review section, this tech document, I've got a figure. So we again see our begin figure and our position specifier. We're centering the figure in the document. For a figure, what you want to do is include a graphic usually. And this is a file that's been saved on your computer in some location that the document knows about. So if we looked here in the graphics folder, we'd see image001.png. That's this image, but it's actually a saved image. So again, this is one of the benefits of LaTeX, is that you are carrying around with you the original source documents for your figures, and you can easily share those with other people or have them, and you're not losing information by including it in the document. So we have the image rendered here. You can specify the width of the figure, either in absolute terms, like I could say that this, I want it to be 6 inches wide, and replace this. Or I can do it in terms of the width of the page. So the command for that is line width. So I'm going to say I want the figure to occupy, let's say, 80% of the writable line or page width here. So I can do that and compile it, and it'll then scale the image to always fill your specified dimensions there. So again, we have our label and caption. The caption in this case is below the figure, so that it renders the caption below the figure, and then the label always comes after the caption. So now we have our figure, and then when we want to reference this stuff, we can again use our reference figure, whatever, figure 1 or figure 2 in the text, and it'll automatically update the numbering for you. So you'll often find, especially in engineering or mathematics applications, that you're going to be writing a lot of symbols and a lot of math. You want to easily be able to reference those as you're going through. So let's look at how you add math both in the text that you're writing, but also in separate equations that are their own line. So I'm going to start writing down here at the end, and let's say I want to include some equation and talk about the values that are in that equation. So the first thing I would do is write some introduction to what the equation is. And then I'm going to actually write out the equation. So there's different ways that you can start an equation environment. If you're just doing a one line, sort of a single equation on one line, you would say begin equation. So I have this far and I hit tab and it'll automatically complete begin equation. And I just write out the equation in LaTeX math. So I'm just going to write out some sort of nonsensical equation. Let's say it's z is equal to x squared plus 3 times y to the x. And let's compile this and see how it looks. So here my text and equation appear. And you'll notice that there's automatically an equation number that's assigned to this. So the equation environment is defined such that it automatically produces an equation number on the right-hand side of the page. If you do want to include an equation that does not have a number with it, you would modify this environment by saying begin equation with a little asterisk, both in the opening and closing, and then compiling that. And then you see that the number does not appear. But let's keep that number for now. And then if I want to reference this equation in the text, I'm going to need to label it somehow. So I would add this label, label, equation. We can just call this my equation. So now instead of saying this equation, I can say specifically that it is equation, this one here. And when compiling, then it's going to reference equation 2.1 automatically. You'll notice that in some of the places there's a tilde between the equation and the reference. And this is just saying that rather than allowing a line break to occur between the word equation and the number, you always want these to appear together in the same line. The tilde forces the two entities next to each other to stay on the same line. Right, so we have now our equation and reference in the text, but I also maybe want to describe something about the equation, maybe define what the variables are, describe them in some way, and you can do that with what's called inline math mode. So as you're typing in your text, you can introduce math into the body of the text using a $sign to delimit the math part of what you're writing. So for example, this might be something like completes the line, right? Of course, you'd make this make more sense. So we can compile this, and now you can see that this math is automatically rendered in line with the equation. So there's a number of different ways to deal with math or with equations here. If you wanted to have just the single equation, you'd do it this way. If you want a multi-line equation or a block of equations, there's a couple ways to do that. A common way is to use the environment equation array, which is begin EQN array. And then you would write multiple equations within this environment. And each line you're going to separate with a double backslash. So you have this, and we compile it, and you'll see that each line isn't going to have its own number. Now, if you wanted to set this up where there's an alignment, a specified alignment, let's say I want the equal sign here to be aligned with the plus sign here. You can do that in the equation array environment by putting an ampersand bracket around whatever the thing you want to align. And then when you render it, it shows up as aligned over here. The last really important thing that I want to talk about is managing citations. LaTeX is really powerful when it comes to citations and automatically setting things up. Again, the goal is you spend a lot more time on getting the template and the typesetting and the commands going, but then once you have done that, the writing process, the citation and automatic numbering and all the figures and equations is supposed to be a lot easier than it is with a tool like Word, for example. That's not universally true, but it tends to be the case. So we've set up our system where this template has a particular citation style that's defined already, so we don't have to worry about that. All we need to do is make sure we have the bibliography information provided to this document, and then we can cite things as we need to. So first, let's look at how the bibliography is structured. Over here, we have a separate file called biblio.bib. If you look in here, there's these different entries that come up. And each entry is going to correspond to a type of document. So here we have a book. This book is a textbook of this title with these authors and so on. So each field has to be filled in for this book type. We have a journal article. Right, here's a journal article that has volume number, pages, etc., information. And then there's these different options for a web page, for another, I guess, textbook in this case. But these are the different entries that we have. Once you have this information entered, in order to cite the document, it's just a matter of using a citation command in the text. So let's go back here, and let's go ahead and cite some of these in the text. So at the end of this line, I'm going to cite. I've got cite, and then I'm going to choose one of the list of citations here. So let's first cite this document. So we do that with this backslash cite, and then when I compile it, we should see that if we go to the location in text, that the citation appears on page 5 of, okay, we've got our citation here in this year format. So you can change the format. This could be author year. It could be just plain author. It could be a numbered format. That's set up in the template. But the actual process of citing in the text is given by this. Now, automatically in this document, whenever you use a citation, you can look down at the bibliography, and the citation will appear in the format that's specified by the document. So it's a really convenient way of dealing with citations. There's a couple other examples here. Again, let's go back to where this is in text. There's a couple other citation examples. Cite will give you the shorthand version of the citation in the document. Cite P gives you a citation in parentheticals. So in this format, we see that the citation is made author year inside of a parenthetical. So it's a way of giving a fuller citation. You can also do things like cite author, which would be done with this command. Again, you're just using the key from the bibliography, the key identifier, but these different commands give you different output. So we could look at how this appears. So we have Duffy et al. Is the long citation. So that's what's being returned. So you might wonder, we look back at the bibliography, you might wonder, this seems kind of like a pain to get this information. So there are easy ways to get this type of information about publications in this format from commonly used tools like Mendeley or EndNote. or Google Scholar. So let's look at Google Scholar and see how we can get that information. Here I've just made some search for some topic of interest. If you note that there's, in this Google Scholar, there's this cite button or this cite link. If you click that, it'll pop up with a list of possible citation styles. But down here at the bottom, you're going to see that there's a BibTeX option. So if I click that, you'll see it takes me to a simple page that shows the BibTeX entry. So you find the relevant citation, and all you need to do is copy this information, come back to your bibliography, and paste it in. And now you can actually cite this publication just as it is in the text. So we would do that. We could go back to our document and then add a citation. So here, let's make this citation here. So here you can see the citation has now been made just by pulling that one reference and putting it in the bibliography. So the last thing you maybe want to do is actually get a PDF out of this, out of the document that you've created. So the easy way to do that in Overleaf is to come up here and click this Download PDF button. It will then provide the PDF that's rendered over here on this screen as a download option. If you want to download the actual entire project, you can do that by going back to your home screen, clicking the or finding the document that you want, and then clicking the download, and it'll provide you a zip file of all the contents that you have uploaded. So that's a quick overview of how you're going to use LaTeX, and particularly use Overleaf to render your LaTeX documents. This tool, the LaTeX tool, is not something that's necessarily better or worse than, say, a Microsoft Word or other typesetting system, but it is different and it has its purpose. And we find that I've found that it's particularly useful in situations where you're trying to construct large, complicated documents, where you have multiple authors that are collaborating, contributing different pieces, or where you want to just set up a template to reuse over and over and not have to worry about the details of getting the template just right, getting the figures and numbering just right. So it definitely has its place, and not everybody likes it, but it's a tool in the toolbox that can go a long way to making the documents that you create look professional and be portable